Hello, once again, ladies and gentlemen, and welcome to our virtual classroom. Today, we're going to be going over Activity 16 practice. And let's begin. We begin with number 1. A car can travel 60 miles per hour. And number 1A, we want to create a table showing how far the car can travel in 5 hours. Now, remember, ladies and gentlemen, that Activity 16 is all about showing the relationship between one variable and how changing that variable will affect another variable, how something is affecting something else. And so if we identify the two variables that we're dealing with here on number 1, notice that we're talking about, well, it's 60 miles per hour. So you have 60 miles traveled in 1 hour. Notice, ladies and gentlemen, that I am relating miles and hours. And as we have seen in the past, it is always going to be your dependent variable on top, your y variable, and your independent variable, the one that comes first on the denominator. So our hours or our time is affecting, as we change the time, that's going to affect the miles, how far something is traveling. So let's go ahead and make a table. And notice that when you go to Schoology, that table is there for you. So it's actually pretty easy to simply put it in there. But I do want you to put it in your notebook if you can. So let's begin. So we begin with hour 0. And it's always going to be this pattern. If you can identify the ratio of the things that you're comparing, typically it is always going to be your independent variable in the denominator, and your dependent variable on the numerator. And you're going to continue to see that. I want you to look for that pattern as we do some of these problems. All right, so in 0 hours, he will obviously travel 0 miles. But in 1 hour, it's given to us here. 1 hour, it's going to be 60 miles. So in 2 hours, we just multiply this by 2, or we add another 60, will be 120. And then in 3 hours, so we go on, so on and so forth, right? So here, times 0, 0. Time 1, 60. Times 2, 120. Oops. Times 3 would be 180. Times 4 would be 240. I'm just going by 60, right? And times 5, how many hours to travel, how many miles would be 300. So it's quite simple, quite simple. All right, moving on. And I hope that that is in your notebook. We move to 1B, write an equation. So now that we know, guys, that it's going to be, well, notice what's happening in our table each time. We need to write an equation. So it seems to me that we're literally going by 60, right? Meaning that we're adding 60 over and over and over again to our, depending on the miles. Sorry, on the hour, right? So we're taking the hour and we're multiplying by 60, and that gives us our y variable. So it seems to me that the distance, miles, is going to be whatever our hour is times 60. It's always times 60, right? And then we multiply by the hour. Notice that here are my two variables. The hour, the independent variable is going to produce our distance. Now it's backwards over here, right? We have, so in order to make sense of this, for example, 5 times 60 is equal to 300. So it's 60 times the hour, which is 5, right? Here's our hour. It's going to equal our y, which in this case is 300, or our distance. And so given that, I can write my equation. Your distance is going to be 60 times the time, 60t. Not 60d, because d is distance, but t because that's time. So these variables actually mean something. Moving on to letter C. How long will it take the car to travel 540 miles? Now, ladies and gentlemen, let's go ahead and use that equation that we just got, which was that the distance, or let's spread it the other way. Let's do 60 times the time in hours is going to equal your distance. All right. And they're asking, well, how long is it going to take to travel 540 miles? So how long will it take? What is going to be the time? We're looking for the time. In this case, we have the distance, we have the distance, but we're looking for the time. And so how can I use this this formula. Now I could continue to go down on the table and just keep counting by 60s, or I can simply do 60 times something. So we're going to do a t is equal to the distance that we're traveling, which is 540. All right, now let's just isolate the variable. Let us solve this equation. Let's isolate this t. So how can I get rid of this multiplication? We can divide by 60 to see what 60 times what will give me 540. But whatever I do to one side, I must do to the other. So 540 divided by 60, I believe is 9. Yeah, sure, because 60 times 9, 9 times 0 is 0, but 9 times 6 is 54. So indeed, ladies and gentlemen, it is going to take me a time of 9 hours to travel that distance. So notice how we're really just going from simpler to a little bit more complicated. I mean, from easier to harder, but it's starting really complicated with a table, a whole bunch of numbers. We're bringing it down to a formula, and now we're using that formula. And now let's see if there's a D. There is. How far? So now we're looking for distance. Can a car travel in 12 hours? Use the formula. Let us use the formula that we just came up with, the equation that we just came up with. How far will it travel in 12 hours? So this time, instead of solving for time, I can use the same formula. 60, let's use a different color. 60 times whatever your time is going to equal a certain distance. Well, our time now is 12. So I can do 60 times the time, which is 12, will equal to a certain distance. Well, 60 times 12 should be, I can't think right now, 72. So 720. 720 miles is our distance. Once you figure out a formula, guys, it is quite simple. It is quite simple. This is the formula that we can use to make this table, to solve for any of these things, right? And so that would be 700. Now, please, please, please do not just get the answers from number one that I just did. If you don't understand how I got them, then you're going to be lost, because I'm not going to work all of these out for you. And obviously, I won't be there for you when you take your test. Let's try. I think we have time for one more. So we just did number one. I'm not going to go through the whole thing, but if you look at number 4, let's read number 4. Emma decided to start a snow globe collection. She started with 3, every year she added 1 more. All right, so if we create a table, same thing. This time, notice that we're doing snow globes per year. So we have globes per year. So this is my Y, or what comes second, and this is my X. This is my independent, the year. So I'm going to do year and G for globe, or I can actually write globe. And let's go ahead and do the table. Notice, ladies and gentlemen, that in year 0, she starts off with 3. That's what she started. And she added 1 every year. So after year 1, she's going to add plus 3. It's going to be whatever the year is, X, and we're going to add 3 plus 3. That's our rule, and that's going to give us our Y. And by the way, that's actually our equation, isn't it? So this is going to be 4. What would it be for year 2, for year 3, for year 4? You figure that on your own. Notice how each time that we increase the X, the year, we're adding 3 because she started with 3 snow globes already. So with that in mind, notice how even when I use different variables than distance and time, it's still the exact same thing. Globes per year, miles per hour. So I'm going to leave that there. I'm not going to give you too much. Hopefully you can figure out the rest on your own. And finally, going down to number 10. I do want to do number 10 because here they want you to come up with an equation, I believe. But they only give you a graph. Well, ladies and gentlemen, remember, this is our X. What comes first is here. This is our independent. So we're going to do something to that X, and it's going to produce our Y. The question is, what are we doing to this X? Well, every time we have X, well, this is 0, right? But if we increase X by 1, Y goes up by 5. We increase X by 2, Y goes up by 5. Sorry, by another 1. Every time we increase X by 1, Y goes up by 5, right? So 1, 5. In fact, if you do a table, we just do x, y. Notice that when x is 0, y is 0. But when x is 1, y is 5. When x is 2, y is 10. When x is 3, it's 15. So what is the relationship? Notice that we're going up by 5s. So repeated addition is multiplication. So we're literally multiplying by 5. And that's it. We're taking our x and we're multiplying by 5. So 5x will give us our y. Notice 5 times our x, which is 3, that should be 15. And that is exactly what I have down here. So that is the relationship. That is how I use the graph. I simply, wherever the x is, you put the y. X is 1, right here, y is 5, good. X is 2, y is 10, got it. X is 3, y is 15, got it. So that is how I figure out the relationship just by looking at the graph. Ladies and gentlemen, I hope, I know I'm not doing a lot of the problems. I don't want to take away the opportunity for you to figure this out on your own, but hopefully those first few examples will give you an idea of not only how to do it, but really get an understanding of how things are working out. And so with that in mind, ladies and gentlemen, I will see you next time.